Today we are going to learn about mastering Pandas join, inner versus outer joins. In this video, we'll explore the differences between inner and outer joins in Pandas, equipping you with the skills to effectively choose the appropriate join type for your data analysis tasks. Welcome to our video on mastering Pandas join operations, specifically focusing on inner and outer joins. Pandas is a powerful data manipulation library in Python, commonly used for data analysis tasks. One of its core functionalities is the ability to merge or join datasets. Understanding how to effectively merge datasets is crucial for data analysis, as it allows you to combine different sources of information, enhance data insight, and simplify complex data operations. In this video, we'll explore the Pandas Merge functionality, delve into the differences between inner and outer joins, and discuss how to handle missing data. By the end of this video, you'll be equipped to choose the appropriate join type for your data merging tasks, making your data analysis process more efficient and accurate. An inner join is a fundamental concept in data merging that combines rows from different datasets based on a common key. When performing an inner join in Pandas, only the rows with matching values in both datasets are included in the result. This means that if there is no match, the row will be excluded from the final dataset. Inner joins are particularly useful when you want to find commonalities between datasets. For example, if you have two datasets of customer orders and customer feedback, an inner join can help you identify which orders have received feedback. Inner joins are beneficial when you need to filter data to only include records that have a counterpart in another dataset. This can simplify data analysis by focusing only on the relevant data points that have relationships across datasets. Overall, inner joins are great for finding intersections between data and are commonly used in data cleaning, data validation, and preliminary data analysis. Outer joins in Pandas are used to combine rows from different datasets, including all records from both datasets, and filling in missing values with NaN where applicable. There are three types of outer joins: left join, right join, and full outer join. A left join includes all records from the left dataset and the matched records from the right dataset. Unmatched records in the right dataset are filled with NaN. Conversely, a right join includes all records from the right dataset and matched records from the left dataset, filling unmatched records with NaN. A full outer join includes all records from both datasets, filling unmatched records on either side with NaN. Outer joins are advantageous when you want to ensure no data is lost during the merge process. They are especially useful in scenarios where missing data needs to be identified or when combining incomplete datasets. By using outer joins, you can maintain the integrity of your data while still gaining a complete view of the combined datasets. This approach is often used in data integration, reporting, and comprehensive analysis tasks. Left and right joins are specific types of outer joins that determine how datasets are combined based on the direction of the join. A left join includes all records from the left dataset and the matched records from the right dataset, filling unmatched records on the right side with NaN. Conversely, a right join includes all records from the right dataset and the matched records from the left dataset, filling unmatched records on the left side with NaN. The choice between a left or right join depends on the analysis objective. Use a left join when you want to retain all data from the left dataset and include matching records from the right dataset. This is useful when the left dataset is the primary dataset for analysis, and you want to add additional information from the right dataset. On the other hand, use a right join when the right dataset is the primary focus, and you want to append data from the left dataset. Understanding these differences and their impacts on data analysis is crucial for making informed decisions in data merging tasks. Inner joins are widely used in real-world data analysis scenarios to focus on intersections between datasets. For instance, in a retail environment, you might have separate datasets for customer orders and customer feedback. Using an inner join, you can merge these datasets to identify orders that have corresponding feedback entries. This allows you to perform a detailed analysis of customer satisfaction and identify areas of improvement. Another example is in sales data analysis, where you have datasets of sales transactions and product reviews. An inner join can help you correlate sales data with customer feedback, providing insights into which products are performing well and which may need adjustments. By leveraging inner joins, you can improve data quality by excluding irrelevant or unmatched records, leading to more accurate analysis outcomes. Additionally, inner joins optimize performance by reducing the size of the dataset to only include relevant records, making data processing more efficient.
Outer joins are particularly useful in scenarios where you need to combine incomplete datasets or identify missing data points. Imagine you have two datasets, one containing customer information and the other containing transaction records. By using a full outer join, you can create a comprehensive view that includes all customers and their corresponding transactions, even if some customers haven't made any transactions yet. This approach helps in identifying gaps in data, such as customers who haven't engaged in recent transactions, allowing for targeted marketing strategies. Outer joins are also valuable in data reconciliation processes where you need to ensure that data from different sources aligns correctly. For example, when merging financial reports from different departments, outer joins help identify discrepancies and ensure accurate financial reporting. Additionally, outer joins support comprehensive data integration, enabling you to combine datasets for detailed reporting and analysis, ensuring no data is left behind. When performing data joins, handling missing data is a critical aspect to consider. Different join types impact how missing data is represented in the resulting dataset. Inner joins inherently exclude missing data because they only include matching records from both datasets. However, outer joins introduce NaN values for missing data points, which need to be handled appropriately. There are several strategies for dealing with missing data in the context of joins. One approach is data imputation, where missing values are filled in using statistical methods or domain knowledge. Another approach is to maintain data integrity by keeping NaN values and addressing them during analysis. It's important to choose the right strategy based on the analysis objective and the nature of the data. Ensuring accurate analysis involves understanding the implications of different join types on missing data and applying appropriate techniques to manage it effectively. This ensures that the insights derived from the data are reliable and meaningful.
Efficient data merging is essential for effective data analysis and can significantly impact the performance of your data processing tasks. One of the best practices is to choose the right join type based on the analysis objective and the nature of the datasets involved. This decision can influence the size of the resulting dataset and the complexity of data handling. Data cleaning and preprocessing are also critical steps before performing data merges. Ensuring that datasets are free of duplicates, inconsistencies, and irrelevant records can improve the accuracy and efficiency of the merge process. It's important to check for dataset compatibility, such as matching data types and column names, to avoid errors during the merge. Additionally, being aware of common pitfalls, such as incorrect assumptions about data relationships or overlooking missing data, can help prevent issues that may arise during the analysis. By following these best practices, you can optimize the data merging process, ensuring that your analysis is based on accurate and reliable data. In conclusion, understanding the differences between inner and outer joins is crucial for mastering data merging tasks in Pandas. Inner joins are useful for focusing on intersections between datasets, while outer joins provide a comprehensive view by including all records. Choosing the right join type is essential for effective data analysis and depends on the specific objectives and characteristics of the datasets involved. Handling missing data appropriately and applying best practices for data merging can enhance the accuracy and efficiency of your analysis. By mastering these concepts and techniques, you can optimize your data analysis process and derive meaningful insights from your data. Thank you for joining us in this exploration of Pandas join operations. We hope you found this video informative and helpful for your data analysis journey.